The human hand is a high-demand biological machine. Powering its complex, continuous movements requires a massive, uninterrupted blood supply. That required volume descends through the upper arm via a single main superhighway, the brachial artery. On this anatomical diagram, we trace the brachial artery down to the elbow, where it splits. The right branch, the ulnar artery, is larger. Following it down to the superficial palmar arch reveals its function, the definitive supply line for the medial forearm and hand. Our manual dexterity relies entirely on this high-volume pipeline delivering oxygenated blood exactly where it's needed. To understand this system under stress, we must isolate where that initial split occurs, a triangular depression at the elbow called the cubital fossa. This animated schematic reveals the skeletal framework. The brachial artery bifurcates exactly at the neck of the radius bone. Contrasting the emerging vessels, the medial ulnar branch has a visibly thicker diameter than the narrower radial artery. That thickness correlates directly to the massive volume of tissue it must perfuse down the arm. By originating deep within the cubital fossa, this highly vulnerable vascular junction is heavily shielded from superficial trauma. Starting from this deep position dictates the protected, subterranean path the artery must carve as it begins its journey through the upper forearm. Routing a major vessel through the forearm presents a structural challenge. The blood must navigate through dense, constantly moving musculoskeletal architecture without being pinched or severed. This 3D map highlights the first obstacle, the pronator teres muscle. The artery dives deep beneath it for protection. Adding the flexor carpi ulnaris to the model, the artery continues downwards, passing strictly deep to this muscle, remaining hidden. The artery doesn't make this journey alone. It forms a critical neurovascular pairing, traveling alongside the ulnar nerve. We can map their relationship here. Overlaying the ulnar nerve, it's positioned medial to the artery. The artery sits securely on the lateral side. Surrounding the trunk are the venae culmitantes, paired veins wrapping tightly to aid blood return. The entire forearm transit relies on this specific configuration, continuous deep muscular cover, and an unwavering neurovascular alignment. While the main trunk descends, it must also supply the surrounding territory. The anterior and posterior ulnar recurrent arteries loop backward to supply the elbow. Just below, the common interosseous artery diverges laterally. It bifurcates almost immediately into anterior and posterior subbranches to feed deeper tissues. Along the entire route, numerous smaller, unnamed muscular branches continuously tap into the line to feed localized tissue. This highly efficient branching architecture keeps the forearm tissues alive without starving the massive volume of blood still heading toward the hand. The real anatomical test occurs at the major spatial choke point, the entry into the wrist. The primary structural landmark we have to navigate here is a tough band of connective tissue known as the flexor retinaculum. In this cross-sectional view, the ulnar artery avoids the carpal tunnel, running superficial to the flexor retinaculum. We can plot its exact micro-coordinates, sandwiched directly medial to the flexor carpi ulnaris tendon and lateral to the ulnar nerve. It utilizes a specific anatomical gateway to cross this threshold into the hand, Guyon's canal. By routing superficially through Guyon's canal, the body ensures uninterrupted blood flow to the fingers, but it sacrifices the deep structural protection it had in the forearm. Exiting Guyon's canal, the artery finally reaches the open space of the palm. Here it enters its final structural phase, terminating by dividing into two distinct paths, a smaller deep palmar branch and a larger continuation. Focusing on the bottom of this anatomical diagram, we can track that larger branch. It loops across the palm to form the superficial palmar arch, while the smaller branch helps form the deep palmar arch. Both of these arches connect directly with corresponding supply lines from the radial artery, creating a fully redundant vascular circuit. This terminal arching structure is a biological failsafe. It guarantees continuous blood flow reaches your fingertips, even when the hand is tightly gripping an object and compressing local vessels. This flowchart maps out the entire systemic blueprint we've just built. The rote facts of its beginning, its deep course, and its branching divisions are an integrated engineering schematic. The stakes of that engineering are high. When blood supply to the medial forearm and hand is compromised, tissue begins to die. Based on our mapping, the structural vulnerability is obvious. Because it runs superficially at the wrist, mechanical compression within Guyon's canal can easily restrict flow. To explicitly test the patency or openness of this pathway, physicians rely on a clinical procedure called Allen's test. By mapping the exact topography of the ulnar artery, from its deep cubital origin down to its superficial palm termination, clinicians can accurately backtrace and diagnose ischemic injuries in the human hand.